Okay, let's get started. So today we have a very special guest, Suresh, from Director of Engineering from Eightfold. Today we're going to talk a lot about customer-facing analytics and AI agents, right? So Suresh is gonna kick off a presentation talking about customer-facing analytics at Eightfold, challenge they face with their legacy solution Redshift and how they solve those challenges, right? And then we're gonna kick off a discussion around AI agents, right? So we're gonna talk about potential use cases of AI agents at Eightfold, especially those customer-facing ones, right? And also we're gonna talk about the unique challenges and how that affect their architectural design decisions related to AI. Okay, so let's get started. So Suresh, the stage is yours.
Thanks, Chira, for introducing. Hello, everybody. Hope you can hear me now. Uh, I'm Suresh. I'm Director of Engineering at Eightfold.ai. A little bit about what we do. Eightfold is an AI company in talent space. To give a context, one could argue that Workday is the last known startup, in the talent space. That's like 20 years ago. From that point to now, I think we are seeing one or two good talent startups which have started in the last 5 years, but there was a large window where not a lot of companies started in the talent space. And Eightfold's unique proposition is it started in AI era. I mean, of course, much before the LLM world, but it started in the AI era. Eightfold started, thinking this problem from AI principles. So all the talent products generally that we can think of, right? Talent acquisition, management, workforce planning. So Eightfold has a product in all these dimensions, and we have large deep learning models to make sure that the candidates are matched to right jobs, candidates are matched with right courses, projects, internal mobility, you name it. We have everything, people. Obviously, one of the biggest challenge with Eightfold technically is, I mean, irrespective of the AI side, is the data. Out of the Fortune 500 companies, more than 200 companies use Eightfold for their careers website. Meaning, when somebody types, say, careers dot, say, Microsoft.com or careers Morgan Stanley.com, all the Fortune 500 companies that you can think of, the traffic is fronted by Eightfold, which means we get the hits first. So naturally, this means our infrastructure and platform has to be highly reliable, and we should capture all this data for analytics. Now I'm going to dive towards the analytics dimension. Happy to take questions at the end, but I'm going to set some context on why we started looking at StarRocks. So the way we designed things at Eightfold is we want to make sure that all these clickstream events are captured. So when we are capturing these clickstream events, we go and write them into our analytics database. And our dimension tables are generally people-oriented tables, employees, profiles, whatnot, right? All the dimension tables that you can generally think about people, we have all of them. Naturally, the size of these dimension tables are pretty large. So to set some context, we have large fact tables, which are clickstream events that are coming from people who are directly interacting with our platform. And we have large dimension tables, which are multi-tenant tables where people have information about their employees, their profiles, uh, their internal data for that matter. So one can imagine analytics is about joining these two tables. That's what we call star schema. So I'll set this context. Just hold on to this. We'll come towards, I mean, I'll start explaining few general concepts and I'll start tying things together. I'm assuming that there are all sorts of audience in who are listening to this webinar. So I'm going to give a brush down on basics, right? So until now we talked about OLAP databases. Generally, people are very confused between what an OLTP database and what OLAP databases are. OLTPs are your MySQLs, Postgres, or anything that deals with direct web application backend, right? This is where most of your primary data is stored. And these are great for point queries. For example, when you do something like select star from employee table where employee name equal to say Sida, right? OLTPs are great for them. You can do a million of them. QPS is not a problem. They are designed for high QPS systems because generally web backends have very high QPS. OLAP, on the other hand, is always thought of as aftermath, right? It is not generally included in your uh, front facing setups. So it is generally thought of as back office setups. This is where technologies like, Redshift, Teradata, Snowflake, BigQuery, all this OLAP technologies are quite popular in the OLAP space. What is the fundamental distinction? The fundamental distinction is in the OLAP databases, we generally don't do point queries. The queries are always like, give me an aggregate of all of this. An example would be, give me the number of employees in the company who is working remote, who is in US location, who is in India location. So naturally, if you can see, these queries span across multiple rows, and we are generally looking for some aggregate value for metrics, dashboards, and whatnot, right? So naturally the database should have different characteristics. Traditionally, people have always designed OLAP databases without concurrency or scale in mind, because naturally this is a back office problem, and our web application is not directly hitting this OLAP database. Rather, an offline ETL job or some offline batch processing job is hitting this OLAP database to find some metrics. Or it could be your BI team too, which is just within the company, who is directly hitting this OLAP database to get some dashboards prepared for internal stakeholders. So we talked about this, we talked about this. And but if you think about it, the cliche term that we people keep saying is data is the new oil. So what it means is, just like Eightfold, every company has ton and ton of data that is growing within the company for their analytics needs. That's why they started spending a lot on data warehouses, because in OLTP, it's okay to truncate and make sure that you have the latest and greatest information to serve the user needs. But in OLAP, it's more like a dump of everything that you have done so far, so that you can do analytics and identify which areas you should spend on. So that's where there's a very high amount of money that is being spent in the analytics world. We talked about this. I'll give you a very brief about general ETL evolution, right? So we talked about OLTP databases, we talked about OLAP databases. Every company generally have their own way of doing ETL between the OLTP systems and OLAP systems. What it means in plain English is, all the data that you have in your Postgres, MySQL, MongoDB, any primary data store will be ETL to your OLAP system, which is the Redshifts of the world, so that you can start analyzing this data. Now there's tremendous technology improvements in this area, where people have started doing zero ETL, where you can directly dump from your Postgres of the world to Redshifts of the world. So the first generation ETL looked like this. So you have structured data, which is your OLTP data, the MySQLs of the world, and the data warehouse, which we just talked about, and this is the ETL which we just talked about. And the BI reports directly power out of data warehouse. So the obvious problems with this world is, data warehouse, just like your OLTP system, has fixed schema. meaning they have their table structures, they have their relationships defined, they have everything that a general OLTP system has. Of course, there are slight nuances like it doesn't have indexes, etc. But more or less, a fixed schema is what is there in data warehouse too. But if you see the machine learning and data sciences use cases, they thrive on unstructured data. Seldom you have use cases where people will say, this is the fixed schema, this is good enough for me. So that's where first generation platforms struggle, which led to the evolution of this two-tier architecture, where people said, I'll dump everything into what is called as data lake. This is where the HDFS of the world became really popular. And the data science and machine learning teams and the internal teams who rely on unstructured data can just query this data lake. But the structured teams like the BIs of the world, the Tableaus and Power BIs, they can't do well with unstructured data. So which means they still needed a data warehouse to make sure that their business is running as usual. So we have a second ETL here, which is basically dumping the data from the data lake to data warehouse. There's the one ETL which is dumping from your primary stores to data lake, and there's a second ETL which is taking from data lake and writing in data warehouse in the format that BI tools care about. Obviously, this solved the data science use cases, but it brought up a new problem, which is consistency. Anybody who worked in data engineering will echo with me that consistency is a big problem between primary stores and your data warehouse. We already had a consistency problem. If you think about it, in the first generation world, we had two sources of truth, and we have this ETL, and we data engineers job is to make sure that the data quality and consistency in this warehouse is to par with the OLTP systems. Now we increase that problem into twofold. There is one ETL that is happening to the data lake, and there is second ETL that is happening from data lake to data warehouse, which means the data engineers have to now worry about two consistency problems, which is increasing the complexity of overall management. The other thing that I want to add is we did briefly talk about HDFS, but the worlds of data lake has completely become popular with the advent of blob storages like S3s and blobs of the world, because durability is no longer a concern. We don't need to manage this large HDFS and Hadoop clusters ourselves. We can just use S3 as a data lake. That's why this pattern become really popular, but we still have to solve this consistency problem. That's where the latest architecture that industry is using is called Lakehouse architecture, where basically they clubbed both of this together, and now you have a single data lake which is called Lakehouse, which can do both structured and unstructured queries. And the structuredness is achieved by a metadata and indexing layer. This is what most of the modern databases are built on, right? Like Databricks, Snowflake. This is how they have evolved. So this is great, right? So what this really gave us is one way of managing OLAP, which can solve all the internal use cases. So the BI, reporting, data science, machine learning, these are all internal use cases. They have structured and unstructured use cases, but they can just be powered on data lake. And you don't need a lot of money to be spent on data lake, because S3s of the world have improved the durability by quite a bit. So you can have a dumb data lake that is on top of S3 and a small computation engine to make sure that we are reading from S3 and serving to this internal use cases. So this is where we were, like 2 years ago. But right now, the world is evolving, right? People's requirements have increased. So people started asking in product analytics, which was not the case at least like 10 years ago. And I mean, even 10 years ago, when there was a need for in product analytics, people were directly powering from OLTPs of the world, because it is not practical to handle high concurrency in the OLAP worlds. It's not that they enjoy doing this on OLTP system. OLTP has several serious limitations in terms of aggregate queries. So people used to do all sorts of magic, drama, cooking to make sure that they get this limited analytics from OLTP system. So LinkedIn, was the first one, or one of the first ones to make sure that they were boldly able to do this in product analytics. So if you see this section on the bottom, LinkedIn has started showing this metrics to the end user. How many profile views, how many impressions, and whatnot, right? And these are generally very hard problems because everybody is going to log into their LinkedIn and you need to show this analytics in sub-second time. And this is where a lot of evolution has begun, right? The traditional OLAP systems were not able to do this at all. So LinkedIn started with Druid, they were not able to scale. Then they started with an in-house project called Pino, where they were able to do all of this. And Pino is now an open source project. So at Eightfold, we had a similar use case. Our data was all on Redshift. This is our OLAP system, and we had a very powerful ETL because we have a domain-oriented ETL. It's not a straightforward zero ETL. So we have a very powerful ETL infrastructure in place, which is kind of taking the data from our primary stores and putting it in Redshift. But our customers demands have increased, and we wanted to show a lot of goodness in Eightfold, because if you think about it, Eightfold is doing a lot for the customers. So naturally we want to show all these metrics in the platform directly, so the end users can directly appreciate how much Eightfold is doing for them. So naturally, something like LinkedIn, we also wanted to show in product analytics directly from an OLAP system. And that's where we started this hunt of finding what is the right OLAP system which can do all our needs. Obviously, we started reading about Druid. Then we looked at the evolution of Pino. Then and we started also looking at StarRocks. One reason we sticked around with StarRocks is other vendors like ClickHouse, Druid, or Pino, they were doing great job, but our requirements are mostly around star schema. Any real world application needs star schema, right? With the fact tables and dimension tables that we were talking about. So Redshift kind of excelled at that. If you think about it, Redshift was inspired by Postgres. It was a clone of Postgres. So the Postgres and MySQL semantics just stayed in Redshift. So designing our schemas and making sure that we give all this goodness to end user kind of stayed good with Redshift. So we wanted to have a database that has this star schema goodness, at the same time give solve the high QPS requirements we have. That's where we learned StarRocks is the latest technology out of all these technologies that are there in the OLAP world, which kind of understood this problem correctly, that we cannot that star schema is a fundamental requirement for any OLAP analytics, because most companies will start dumping data in the form of fact tables and dimension tables, and these large joins are not going away. And that's where this innovation of keep your data as is, but we'll still solve high QPS requirement for you, was the game changer for us. Now we look at what fundamental problems we observed in the current technology, and how StarRocks, according to our research, have solved this, right? So this is a brief overview of Redshift architecture. So now I'm going to go a little technical. Please bear with me. So at a high level, Redshift, was inspired from Postgres. It was a clone of Postgres, and it has its own journey, right? Uh, Redshift is a distributed system. It has a leader node, and all these are compute nodes. We talked about separation of storage and compute already. We know that the data is existing in the data lake format, which is in S3, and this compute, this green box here, is a stateless entity which can directly read data from S3. The compute nodes can be added as many as you want, but the fundamental bottleneck here is the leader node. So all your queries are going via the leader node, and the leader node is kind of orchestrating how the queries have to be executed. And if the leader node is quite busy, it will kind of queue the rest of the requests. So this was designed in the assumption that we talked about, where this uh, OLAP system doesn't need a magical QPS component. But this is where our limitation was. If you have a single leader node, our QPS cannot be beyond what a leader node can handle, even though you add as many compute nodes as possible. Some of the answers these existing technologies have are: why don't you create a new cluster? Why don't you shard it yourself? Why don't you do serverless? All of this had severe limitation in terms of management, because we have to do a lot of management if you manage multiple clusters and do a client based sharding. So there's a concept of concurrency scaling too, but that also involves significant delays to spin up new cluster. And also there are limitations in terms of number of concurrency clusters you can have. At max, this technology supports up to 10 to 11 concurrency clusters. So we wanted a system which will remove all these limitations, and where we can scale infinitely both the leader nodes as well as compute nodes. That's where StarRocks came into picture. So to summarize, the bottlenecks where we had a single leader bottleneck. There's no concept of partitioning. We'll talk about partitioning in detail. Concurrency scaling is expensive because we have to spin up large number of new clusters, and it's time consuming, and there are also limitations on number of horizontal clusters you can spin off. Serverless do not have a lot of EBS benefits. We should talk about this. So we talked about separation of storage and compute, which means all your data is there in S3 bucket and your compute is a stateless entity. So when a query is fired, what really happens is the compute, which is the cluster in this case, should get the data from Amazon S3 or any other blob storage, and it should bring it to the EBS volume. So in order to bring it to the EBS volume, it has to do a lot of IO. Uh, Give me 1 second. Yes, it has to do a lot of IO. So which means it's time consuming. Uh, so it is in our best interest to cache as much as data from the S3 to the EBS volumes or any volumes on the compute node. That way, we'll reduce this IO. We all know IO is slow, especially on object storage. So one of the fundamental requirement for QPS is not just leader node scaling, ability to handle multiple queries in parallel, but also the amount of time you are spending in IO and CPU, right? So that's why it is important to have a large EBS volumes on all of these compute nodes, at least to the point where you want the data to be. And you will then start achieving QPS because you no longer need to do IO for every request. That's where we saw a significant problem in serverless. While serverless is great because it provides a lot of concurrency, it has this fundamental limitation of data not being present in the EBS volume when we desire. So concurrency is still a bottleneck because each query is still going to be expensive. It's not that serverless is completely bad. Serverless will still have the data in the EBS volume to certain extent. But the nature of serverless is we don't want the compute to be on all the time, and we'll shut down the compute, you know, whenever things are not being used, and clean up the EBS volumes, because we have to make room for other multi-tenant systems who are using the serverless compute. So that is why the data that we frequently use no longer consistently present in the EBS volume. So our design, what our team decided is we need a fixed compute. Serverless is not an option for us. We need an EBS volume to cache all this data. At the same time, we still want to have the separation of storage and compute, because we don't want to keep all this data in the compute layer itself, because you then have to worry about durability. S3 already solved the durability problem for us. If you don't have S3 in the picture, and if all the data is there in the cluster, then you need to worry about redundancy. Then you need to make sure that there are multiple copies of data within your cluster. Then you need to worry about replication. So which means inherently you have to start adding a lot of computational nodes. So we didn't want to deal with all of that, and we want to keep cost in mind. So we took the goodness of Redshift, which is separation of storage and compute, and any solution that we are researching should continue with this goodness of separation of storage and compute. At the same time, bring in new concurrency and QPS benefits. Now, if you think about StarRocks, it started solving exactly the same problems that we talked about. There's no single leader bottleneck. There's a concept of front end nodes where all the front end nodes can be infinitely scaled, and back end nodes, as we know in any technology, can be infinitely scaled. And the distributed storage here is still S3, which means the separation of storage and compute still existed. The distributed storage will be used as the data lake, and the leader nodes will then distribute all the queries across multiple backend nodes, and there are multiple leader nodes to kind of distribute query plan and aggregate the results and send it back to the client. So that's roughly how we ended up picking up StarRocks. This was one of our P0s, and not a lot of high QPS OLAP systems were offering this kind of simplicity. And the second factor, obviously, is also to keep the system very simple. The other competitors and other technologies had a lot of moving pieces. We had to install Zookeeper, we had to do this. Of course, when we go to manage service, some of these things will be simpler. But even for an infrastructure engineer to comprehend all of this and manage all of this is slightly trickier when we have a simpler alternative like this. So that's how we picked StarRocks. Now we'll talk about partitioning for a few minutes. It'll give you a nice idea of how concurrency is achieved after all of this goodness. So we talked about this. StarRocks does not have a single leader bottleneck. So it has FE nodes, unlimited scalability, no concept of partitioning in Redshift. There's partitioning. We'll talk about it in detail. Concurrency scaling was expensive and time consuming. Max is 10. Here in this architecture, you don't have to worry about concurrency scaling. You can add unlimited FE nodes and unlimited backend nodes. Serverless is not an option for us because we need the EBS benefits. Now we'll talk about partitioning. For Redshift, roughly you can think of it this way. Yes, there is separation of compute and storage. We had a leader node. There is an EBS cache in almost all the nodes, which was essential for query performance, and the data is there in S3 bucket. When you actually write the data is stored in something called immutable blocks. These are 1 MB blocks, which are stored directly on S3. But who is responsible for what data? So Redshift has something called computational slices. These are, think of it as virtual units, which is how the cluster is divided into. For simplicity of this example, I'm going to make few assumptions for discussion. So just to imprint the idea in your head, but the fundamental nuances could be slightly different. So for the purpose of this discussion, assume that each compute node has 4 slices, and in a 4-node cluster, there are say 16 slices. And whenever you write data or read data, one of the slice is responsible for your data based on the distribution key. For example, let's say tenant ID is your distribution key. That's the common distribution key in most multi-tenant systems. So what happens is, out of the 16 slices, and let's say you have 100 tenants, you can think of a simple hash function where this 16 slices represent this 100 tenants uniformly, and each slice is responsible for reading and writing the data. So one of the inherent problem here is, let's say out of these 4 slices, which are say handling the traffic of 10 tenant IDs, for example, the slice should obviously handle more than one tenant ID because there are only 16 slices and you have 100 tenants. So if this slice is reading and writing data about one tenant ID, it will obviously be busy. Let's say there is a very busy tenant ID or a very large tenant ID. There's no fundamental distinction of which slice should handle what, because you will always be limited by the number of slices. You cannot have one slice per tenant ID. That is not simply possible. So one can easily see you'll start getting into this noisy neighbor problem. Imagine a slice A which is dealing with a very large customer like a Pepsi, and at the same time very small customer like any startup, right? So if Pepsi is continuously bombarding the OLAP system, the small startup will always suffer because it will not have the cycles of the slice to read and write the data. So what we really wanted here is we wanted to remove this limitation. Another alternative could be, one could question, why do we really have to shard by tenant ID? Why not just shard or do an uniform distribution so that all 16 slices can worry about all the data? The problem there obviously is if you do something like this, when there is a read query or write query, all the nodes in your system has to participate because you are doing an uniform distribution. And when you do select star from table where employee location equal to US, all the compute nodes have to start working. That is how the uniform distribution works. And even when you do that, our Redshift cluster was bombarded because few major customers were taking the bandwidth of the entire system, and the smaller ones are always suffering. So, and obviously, since you have to do a lot of work, your performance will also be bad because now there are all computational nodes involved for answering a single query, and you have to stitch back all this data from all these computational nodes. So what we are really looking for is partitioning of data, a group or tenant ID or a group ID level partition. So how did we model this in StarRocks? In StarRocks, think of this yellow box as your S3 bucket, which is this box. And instead of storing 1 MB blocks, which are not tenant ID dependent, StarRocks allows us to partition them by tenant ID. Few basics to think about. StarRocks fundamental unit is called a tablet, which is very similar to the 1 MB block that we talked about. Uh, StarRocks allows this virtual partitioning, which means for every tenant we can create a partition. The tablets are then mapped to backend nodes. So tablets are mapped to one or more backend nodes, right? This way, what we are really saying is you can continue having your distribution key as your tenant ID, but at the same time, you will hardly have a noisy neighbor problem because more than one backend node is participating on the partition. In the slices model, there's exactly one compute node that is participating in your read or write queries because slice is always associated with a compute node, and we discussed that slice will only operate on the data for that group ID or tenant ID. But in case of StarRocks, in this setup, there are tablets are assigned to multiple backend nodes, but there is a virtual partitioning or a partitioning concept which is making sure that all the data related to a customer A will always go within this partition. So leader nodes plus this partitioning technique improved the concurrency quite a bit using StarRocks. Roughly, you can imagine the data layout is going to be like this, right? There are backend nodes. You can horizontally scale them, and there are tablets. Each tablet here is a customer's tablet. So the tablets will be uniformly distributed like this. So when there is a query about customer one, you can see that we have distributed the data across 5 backend nodes. So even if there are 100 backend nodes, the data will be there in 5 backend nodes because we choose to distribute it like this. So when there is a query, there will not be a single point of choke point. All these 5 backend nodes will parallelly participate, get the desired result, aggregate, and show it at the same time without killing the cluster performance. I would like to stop it here and obviously take more questions from the users and dive deeper. But I just wanted to give a very high level overview of what motivated us to look towards StarRocks when there are tremendous amount of technologies in this space. Yeah. Any questions, Sida? Off to you.
Sorry, I was muted. Any question from the audience? Do we have any question? If I have any question, now is absolutely the time to ask. Okay, so let's move forward. So thank you, Suresh, for this amazing presentation on your customer facing journey and all of the challenges that you solve. Right, I'm sure a lot of users can can relate to if you want to do customers facing with a legacy cloud data warehouse. All the challenges that you guys face. Right, and now before we actually wrap this up, I want to shift the gear a little bit. Right, so increasingly, it's not only just human interacting with analytics, right? It's LLMs, it's agents, it's AI powered system that needs to query, that needs to reason, that they need to act on the data autonomously, right? Often in real time, in even more concurrency, right? On even massive amount of scale, right? And Eightfold is one of the few companies I've seen that's actually already started exploring this area. As this what this next generation would look like, right? So let's say the next like 10, 15 minutes talking about this emerging space, right?
Mhm.
Agentic analytics. So
Yeah.
what it means, why it matters, right? And what it takes, to build this kind of infrastructure for itself, right? So Suresh, maybe to kick us off, can you share what agentic analytics means to you and what Eightfold is thinking about it now and why Eightfold is thinking about it now?
Yeah. So, agents are the new way of programming now, right? So, because these LLMs are becoming powerful day by day, uh, it is only natural for us to adopt this because it is solving quite a few of problems for engineering companies, right? You right now we are in a world where you don't need to write a lot of business logic, and you can use agentic infrastructure or agentic style of programming to rely on LLM to uh, tie the business logic so that you can just focus on writing your tools or writing your utilities for agents to orchestrate. So that's the new style of programming that we are evolving towards. Agents can do a lot of things, right? So for example, there are a lot of workflows which we can rethink using agents. Previously, the workflows are completely static, pre-codified, and end to end, completely thought of, right? But in the agentic world, you don't have you can code workflows in a different way. You can divide problems into sub problems, and you can delegate each problems to agents. Agents will query the database in behalf of you. Agent will kickstart a workflow for you. So that's the new style of programming that people have started adapting. And Headfold, being an AI company, we started doing this well before anybody could catch up, right? But in the context of analytics, I'm not going into the agentic world a lot because I'm assuming people are familiar with that. I'm going to talk about the piece where how agents and OLAP worlds are tied together. If you think about it, agents will do a lot of queries behalf of the user. So they can either query your OLTP systems or OLAP systems, which means more than human, the agents are going to continuously bombard your OLAP systems to get some data points to continue their workflow or go to the next step of their workflow. I mean, that's how people are architecting agentic systems, right? They are architecting systems in a way that agents are going to automate a lot of workflows for them so that they don't have to sit in front of a computer. They can do better things, right? So which means more than humans, agent is going to completely keep your platform and infrastructure busy by bombarding your databases. So that is why QPS is extremely important, especially if you want if you want to let agents to query your OLAP systems continuously. In addition to this, what everybody and Eightfold also think about is conversational analytics. So people don't want to look at fixed reports or fixed dashboards because it is very hard to kind of encapsulate all user requirements into a single report. In the past, people have faced this, people have expressed this, but now this, because of LLM, this is a possibility where people can come and freely ask a question in your system, and we should be able to answer it for them, which means they'll start entering questions like GPT. where, oh, how many total hires we had this quarter, what is the status of this candidate, what is the status of that candidate, what happened to this person's internal mobility, right? All these questions should be streamlined, and an OLAP system should be able to answer all of this. That is where, because we have StarRocks in our system now, we are now able to boldly think about all this high QPS queries that can come into our platform. And we started freely innovating. Of course, these are still in progress, but we started freely innovating on uh, assuming that high QPS OLAP is no longer a problem because StarRocks can do that for us.
Okay, that's fantastic. So there is actually a space, for agentic analytics. It's not only for like internal use cases, not only for you to build like batch pipelines, but also to serve that kind of uh, automation, right? That
Yeah,
kind of like self-optimizing,
yeah,
right, SQL and analytics directly to your end user, right?
yeah,
That's really exciting to hear, right? But I also have a little challenge here. So it comes with a lot of automation, but it comes a lot more with challenges around access control, around permissions, and how to protect your sensitive data, right? What kind of guardrails you think are important, to build trust in this kind of a new agent world we're living in right now.
yeah. So thanks for the question. Good question, by the way. So this is where pragmatism comes into picture, right? Uh, we don't want to allow free form analytics queries to your database without a guardrail or without a permission boundary, because at that point people will start asking questions that they are not supposed to know answers for. And I mean, if you let me, I would simply ask, what's my manager's salary, right? I mean, that's not how
Yeah.
it's supposed to be, right? But at the same time, the deeper question here is, where should the permission boundary exist? Should it exist in a database like StarRocks, or should it exist in your application layer? If so, how will StarRocks understand it? So these are, the areas that we are still thinking about, and we are innovating. But what my take on this is, we need to have a permission boundary that your application and StarRocks should both reference, and that should be the single source of truth. Because there are many databases which tried this approach of having an inbuilt RLS. It will work for many cases, I'm not denying that. But for cases like this, where you want agents and users and multiple people to kind of use this centralized system with access control, every application is going to be different. StarRocks or any database for that matter cannot simply comprehend the kind of access control rules a large enterprise company is going to have. Yeah, it can, we can codify a little bit, but it cannot understand the entire complexity. So my
Yeah.
recommendation, or what I'm thinking about, is to have an intermediate permission boundary, which your application team will kind of continuously populate, and your application will simply reference this permission boundary framework to understand what are the authorities or what are the access controls for the current user that is logged in. And that will automatically change your query before it hits StarRocks. I would
Yeah.
like to keep my OLAP layer simple and let my application layer deal with the permission boundary, because it's not just StarRocks or Databricks for that matter, right? You will have several places in your infrastructure. Maybe you need the same access control on your Postgres, maybe you need the same access control on some other third party system that you are using. We cannot be replicating this permission boundary into all of them, so having them in a centralized place is ideal.
That's terrific. So let's say if we fast forward 6 to 12 to 24 months, right? What would success look like, for agentic analytics, at Eightfold? What kind of use cases are you guys thinking about?
Yeah, I mean, my ambitious goal is, if we can have a GPT like platform where customers will have a very simple GPT like platform where they come and type any question, and they should have an answer in all fancy formats that they care about. It could be a
Yeah.
report, it could be a CSV, it could be that. I mean, in fact, I'm thinking about, somebody could simply upload their templated PPT, PowerPoint presentation, and ask
Yeah.
this platform to say, hey, can you build the hiring report for the last quarter, and it should
Yeah,
query your OLAP system. It should have your templated PPT. It should fill everything, and it should have a downloaded copy for the user to present. So I don't want any pre-canned report. I just want a free form report with just conversations. That's
yeah.
my.
Yeah, the end goal is never just OLAP, right? OLAP is just part of the process, right? It's
Yeah,
all about how you serve the final purpose. Like multiple different kind of agents that are
correct.
working together, right? Sharing the same open data, right? In the Lakehouse. That is absolutely fantastic to hear.
Mhm.
Okay, so my last question would be, for teams just beginning to even think about this AI native analytics or agents, what advice would you offer? And what to look for basically.
Yeah, I mean, look at your QPS requirements first. Start simple. Uh, I think invest invest in a good OLAP database first, because that is going to set up your framework for the next few years, saying that this database can handle the load. Start simple. Now, at the same time, I think you guys know how to invest in the agentic worlds or the AI world, so I'm not going to talk about that. So the feeling, I mean, what people are generally doing is they're doing a good job investing in the agents and AI part, and worrying about the infrastructure pieces kind of late in the game, because this is migrating, architecting something like StarRocks is not going to be simple. Right? It's not going to be days worth of effort. It'll be at least few months to migrate from your existing OLAP to this. There will be a new ETL to think about. There'll be new use cases to think about. So get your
Yeah.
fundamental data layer solid. Then building agents on top of that is not hard.
Okay. That's really great. That's really great. Thank you so much, Suresh, for your insightful talk and the discussion, answering my questions. Okay, is there any question from the audience? Let's see. Okay, so we have some questions here in the Q&A. So first question, what model is considered here, like share data or share nothing architecture? I think this is referring to your presentation before.
Share nothing. The data is all in S3.
Okay.
I mean, I don't know the term correctly. I
Yeah, it's shared data. So it's
Oh, it's
all
shared data.
shared in
Yeah.
S3. Yeah, so
So
it's
basically,
shared
yeah,
data.
correct. I just want to reiterate that we don't want to store the data in the computational nodes or at all. The actual copy of the data should be in an S3 bucket.
Yeah,
The EBS volumes in the compute nodes or backend nodes, whatever you want to call, is only a cache. If you don't have S3 in the picture, all the data will be in the cluster, and we have to worry about redundancy.
that makes sense. Next question, I'll make it public. Um, why in the end B shows instead of CN if S3 is used?
Yeah,
Okay, I
so
think this is a terminology.
yeah, I'm using them
Yeah,
interchangeably, but the
yeah,
idea
yeah,
is not to store. The idea is to store everything in S3.
yeah. Persistent S3 and a cache in your CNs, right? So you get the best of the both worlds, right?
Yeah.
And we have a lot of like mechanism built into the cache, to make sure that it always hits.
Yeah.
So next question. This question is just thanks, thank you again. And the next question. Thank you for the great announce. How many? Okay, let me reword this. What was the total TCO change?
Yeah.
Like going from Redshift to StarRocks.
Yeah. So I'm going to keep it simple, right? Roughly, the performance is 2x. There's a 2x improvement compared to Redshift. It'll be more based on your queries and use cases, but I'm going to take the worst case, and in the worst case we have seen a 2x improvement. And cost, I think you will see a 2x drop in your cost, especially when you start scaling. So there's a 2x drop in the cost and the 2x improvement in production. That's what we have seen.
Thank you. Next question. Read it out. Does StarRocks provide sufficient low query latency? for your customer interfaces and your agents.
Yes, it does. So it also involves some part of data engineering. You need to make sure that there are, that tables are created correctly. That you have to take advantage of this async materialized views. There are a lot of goodnesses that StarRocks offers, right? When you create a materialized view, and when you try to refresh it, StarRocks can refresh it partition by partition, as opposed to refreshing your entire materialized view. So which means you have to architect all of these features correctly to get advantage, right? Yes, you if you architect them correctly, you will see a significant UPS for customer use cases.
Thank you. The last question I see right now: if data is stored in S3, then how do you use B for data partitioning?
So it has no bearing with data being in S3. So as we talked about, the tablets are fundamentally the unit of storage, right? Whether the tablet is stored in S3 or whether the tablet is stored in your backend node or computational node, whatever you want to call, has no bearing at all, right? It is just a place to store your data. The other concepts of partitioning is fundamentally the same. If the if the tablet is there in your S3 bucket, there will be an association to tablet to bucket ID. And if the tablet is directly stored in the computational node or a backend node, it is already present in that particular backend node that we're talking about. And it is replicated to multiple backend nodes for durability. So your query can be answered by either the host node or the replicated node. But being in S3 does not affect partitioning.
Okay, we have. Thank you for the answer. Um, and there's another question, another new one. What's the data freshness of your use case? How do you refresh the materialized views?
So there are both. We have both styles of use cases. We have near real time use case where most of the near real time use cases are powered using fact tables directly, and async MVs on top of fact tables, so that you don't have to worry about size of your tables. And async MVs get quickly refreshed, or your fact tables itself can answer these queries. But the places where you have joins, where you have high joins, high cardinality joins, that's where we end up using materialized views. We have taken a hit on freshness because we want performance on this materialized view. So depending upon the type of use cases, StarRocks provides you ways to architect both.
Yeah, thank you. It's all about the trade-offs, right? And now we have three more questions. So, um, it was a continuous of the last question we talked about. We're S3, right? And how the tablet associate and partitioning. So the follow-up question is, then OBCN nodes should be able to participate in the query, right? Um, yes.
It should be able to, but
Yeah.
the thing is, we don't want it to. In if you we still want to partition it by tenant ID, which means, see, there are few things, right? We don't want a single backend node to participate, which is what was happening in Redshift. We
Yeah.
don't want to change the distribution key. If you change the distribution key, all the nodes in the cluster, if you have 100 nodes in the cluster, all 100 nodes will participate. We don't want either. We need something in between. We don't we want few nodes to participate. We don't want a single node bottleneck. At the same time, we don't want all the nodes to participate, because it will kill your cluster. So by this
Yeah.
partitioning and tablet strategy, the tablets are assigned to few backend nodes out of n backend nodes. And when there is a query, only these few backend nodes will participate. And if you do uniform distribution, for every query, multiple such few backend nodes will participate. Overall, the cluster will be healthy.
Yeah. So yeah, it's all about the trade-off, right? Shuffling is great. You have like a hard cardinality, like an aggregation or large join between the two large table. But shuffling is inherently still pretty expensive, right?
Yeah.
Although the way we do it, but it's still like network cost there. Next question. What are the challenges if we are planning to use BE instead of CN? We want the highest possible QPS, in which we were informed that using B is better compared to CN. So basically, trade off between share data and share nothing.
Yeah, so that's correct, right? See, if you think about it, if you remove S3 from the picture, If you remove the blob storage from the picture completely, your IO cost is going to go away. All your data is there in your node directly on your EBS volume, so performance is going to be better. If you absolutely care about performance only, QPS only, and if you are not worried about cost, go for it. But the challenge is if you don't have S3 in the picture, you have to worry about durability. So you will start managing multiple copies of tablets if you don't have S3, because if the node itself cannot offer you durability, right? EBS volume itself cannot offer durability. The node can go down, the volume can go down. So you need to have replication factor where you have to replicate the tablets. So if cost is not a concern for you, and if you only care about QPS and performance, S3 is not a requirement. But in a practical setup, you need to make sure that the data is distributed. The other use case I can think of is, uh, once you have an S3 bucket, you can choose the table format that you care about. For example, one could say, I would just want to write my data in, iceberg format or delta format or whatever format that I care about, because this is what I want to do to avoid any form of vendor lock-in. Tomorrow, if you want to replace the OLAP technology with something else, you don't have to worry about, because your S3 bucket has the data in iceberg format without any vendor lock-in, and you can simply bring in a new computational platform and attach your S3 bucket. But when you only use this backend node setup, your data is completely tied within the StarRocks or any other technology in the native format, and migration is going to be a challenge. So it's all trade-offs, right? Whatever you want, you can architect in that way.
Yeah, yeah, it's all about the trade-off, right? It's about like, do you have your, your traffic, right? Does it have a peak, right? Do you have to scale, right? And that really affects your decision. And like, is there, can you withstand just a few, even just a few slow queries, right?
Yeah.
Caching can solve a lot of problem. We're really working hard to eliminate all of the, the cache misses, right? But things still happens, right? Um, Next question. Roughly what percent of your data do you see being stored in EBS volume in CN nodes so that your queries are faster?
I don't know the number on top of my head, but it depends on table by table, right? Because every table and every use case is different. Some smaller tables or smaller MVs, you can pull all the data and put in EBS volume. StarRocks automatically does it for you. But if your fact tables are extremely large, it is unrealistic to store all this in your, EBS volume, because this is terabytes of data. So based on our query patterns, I am assuming that 10 to 20% of data will be there in EBS volumes. And that is good enough in most cases, because the queries are kind of repetitive and they kind of hit the same time range again and again. Very rarely people will ask something about what happened 2 years ago, even though we are expected to store them. So for larger tables, maybe 10%, but for smaller tables, maybe the entire table. But I don't know a single number on top of my mind.
Thank you. Let's see. The next question. Two more to go. I want to learn more about materialized views. How do you get such a good understanding of it?
Okay, I mean, I would probably refer that to SIDA. So it is there in official StarRocks documentation.
Yeah.
It is just like any other materialized views that you see in OLTPs and OLAP worlds. The goodness here is you will be able to refresh it partition by partition, as opposed to refreshing the entire materialized view in one shot. What really happens, I mean, see, at the end of the day, MVs are again tables, right? They are persisted on disk. That's why it's materialized. So when you are creating a large materialized views, you have to worry about your CPU. The CPU will take a hit, right? And other parameters too, right? When your CPU takes hit, your queries will start becoming slow. So you need a system where your MV should be able to refresh without worrying about the cluster's performance. So that is why this async MVs and refreshing partitioning by partition is very important, because they do a calculated approach without killing the cluster.
Yes. Yeah, so definitely go read the documentation. And the documentation actually has a few use cases and examples you can read just in the query acceleration section. and just go down, you can see asynchronous materialized view, and this is what we're talking about, right? The other synchronous is more like a roll up for single table for real time, right? Okay, so okay, still two more left. Are you using multi-warehouse to achieve isolation of groups and nodes participating in the query?
We are using multi warehouse for separating the writes and reads, but not for multiple groups, multiple tenants yet. We will get there at some point if needed, but ideally we want to keep our writes and reads separate, because in the writes cluster we also want to do this periodic vacuuming and whatnot, which will obviously utilize a bit of CPU. In our reads, we strictly want the read cluster CBS volumes to have the latest and greatest copies of data, so we can just do high QPS without worrying about interrupting reads and vacuums.
Yeah, yeah, that makes sense. Last question. How much performance improvements if we do share nothing versus share everything, share data? Um, and I was also informed that scaling B is harder compared to scaling CN.
I'm going to rephrase the question in the language that I understand.
Yeah,
You are probably asking how much performance improvement if there for if you have a setup where there is no S3 versus S3, right? See, obviously it depends on your use case. If you are always querying all the data all the time, right? For example, let's say you have 5 years worth of data, and if you're querying all the 5 years worth of data all the time, and if your data is continuously changing, right, cache is going to be invalid and you have to pull or read from S3. So if you have a continuously changing use case, or if you want to query all the data all the time, yes, you will have a very good performance if when all the data is there in EBS volumes as source of truth versus an S3 bucket. But in reality, in most of the cases, you don't need this, right? You will have, if you architect correctly, you will be able to get this done with S3. S3's IO is also improving, by the way. Now there are fast IOs in S3, which is trying to reduce this problem incrementally. So if you care about, if you're building a gaming platform where you need a leaderboard, where you want all the data to be fresh, available instantly, near real time, maybe S3 is not the right solution for you. But if you are building an enterprise scale OLAP system where customers are going to query a part of data, but they still need a real time user experience, S3 is fantastic because you have a data lake to store all the data. You only query the necessary data. The necessary data is there in your EBS volumes, and concurrency is achieved because you almost always don't have to go to S3 after the first query. And you don't even have to wait for the query to go to S3. You can periodically warm up your caches too, right? To give an user experience that everything is coming from EBS volume. So it really depends on your use case. Uh, yes, you are right that scaling without S3 is hard, because then, as I told you, the durability is a problem. The data and the tablets are going to stay in your cluster, and if the node goes down, you have to worry about replication. You have to worry about making sure that the cluster is up to date with all the data that is required. So scaling a setup which does not have S3 requires a lot more planning and a little more complex because of the durability aspect, but it's trade-offs.
thank you for the thorough answer.
Yeah.
I think actually one more.
Yeah.
um, thanks for answering. If your team using Redshift, then maybe use WLM.
Yeah.
Is there similar features on StarRocks? What is your filing?
So first of all, we did use WLM. WLM is necessary for improving the concurrency, but at the same time, as I pointed out, no WLM etc. are Redshift answers to improve the concurrency. They are great technologies, but we still have this founding limitation factor, which is leader node bottleneck, which is not letting you scale more than 50 queries. WLM is more about I have this 50 queries. How do I handle this 50 queries? How do I give priority to this 50 queries? But it cannot magically increase the number from 50 to 500, right? As in, does is WLM like feature available in StarRocks? We have not experimented with that. I think so, but I have not experimented with that, because the way we architected our queries, we were able to get good performance for all the queries.
Thank you. That's all of the questions we have for now. If you have any more questions, please join the StarRocks Slack channel, and you can directly interact with us over there. Thank you, Sarish, for the wonderful session. We're a little past an hour already, so thank
Okay.
you everybody for joining. See you guys again next time. Thank you.
Thank you.
Thank you.